All right, in this video, we're going to be talking about Learning Objective 6-2, which is to describe qualitatively and calculate quantitatively how frequency, wavelength, and wave speed relate in a constant medium. So we got three things: frequency, wavelength, and wave speed, which you should know from the previous video. And we're also talking about it in two ways. So we're describing qualitatively, meaning without numbers, just descriptions, and we're calculating quantitatively, meaning actually doing the math with numbers. And we're looking at these wave relationships. And we're going to start with a really fundamental idea about waves here in this first sentence. It says, if the medium is constant, meaning that the air or the water that this wave is traveling through is not changing. It's not changing in temperature, it's not changing in pressure, it's not changing in type of material, then the wave speed will also be constant. And we should see that in, investigations that we're doing together in the Gummy Bear Wave Lab. If you've done that, then you're going to have waves being created in that simulator, and you're going to see the waves traveling through the simulator. And basically, the only way to change the speed of those waves is by actually changing something about the simulator, by adding tension to it, or by decreasing the tension, or by adding mass of gummy bears, or changing the location of the gummy bears. You have to change the medium to change the wave speed. If the wave speed is constant, then the next step is frequency and wavelength have to have an inverse relationship. So we're going to look at this picture right here as an example. This wave has a long wavelength and therefore a low frequency, whereas this wave has a short wavelength and therefore a high frequency. And we should know this from the previous learning objective, that if the waves are all moving at the same speed, higher frequency waves have to be compressed closer together and have a shorter wavelength and a higher frequency. So just knowing that inverse relationship visually is really helpful. And that's how we will describe it qualitatively. Just being able to look at a wave and say, is that a long wavelength or a short wavelength? Is that a high frequency or is that a low frequency? Remember that it's an inverse relationship. The next step is to look at what we call the wave speed equation, which is we have written right here. And this describes the relationship mathematically. It also shows an inverse relationship between frequency and wavelength. Okay, so what do these symbols mean? We have a V. The V here represents wave speed, which is measured in meters per second. We then have F, which represents the frequency. That's not surprising either. Frequency is measured in hertz. Hertz is also known as waves per second. And then lastly, here in purple, we have this weird symbol. And this weird symbol is the Greek letter lambda or lambda. You can say it however you'd like. Lambda represents wavelength, and wavelength is measured in meters. When we use the equation, if we do the same thing and we say that the medium is constant and therefore the wave speed is constant, then the V in the equation, the V right here and the V right here have to remain the same. If that's the case, if you plug in a large value for F, you have to plug in a small value for lambda in order to get the same wave speed out of the equation. And so a high frequency gives a short wavelength. On the other hand, if we plug in a large value for lambda, then we have to get a small value for frequency in order for the wave speed to still be the same. And so a low frequency is going to create a long wavelength. Again, we're getting this inverse relationship from the equation. Now you also need to be able to find values of wave speed or frequency or wavelength and plug them into that equation and do algebra. But you guys already should know how to do that. You've seen many 3-variable equations in this class already, whether it was Newton's second law, force equals mass times acceleration, or momentum, which is P equals m times v. So you should know how to do this algebra. And if you don't, it's not really something I'm going to explain here.